Hello, I'm Atindra Chaturvedi. In the previous video, we had examined Network I/O Control version 3, also known as NIOC version 3. In this video, we are going to look at ESXi 6, Command Line Interface CLI for networking. Most of the activities we're going to do are in the ESXi shell. I will log in using the secure shell into the ESXi shell, but we will first begin by taking a look at the overall server that we are looking at, and for that we are going to go to the web client. So we are now into the VMware vSphere web client. I have that same server 192.168.0.201 out here, and I wanted to show you in the Manage Networking tab the virtual switches that actually exist here. So there is essentially one standard switch, vSwitch 0. That's the only switch that's out there. You have the standard management network port group and the standard VM network port group. And I have two other VM kernels here, VM kernel ports, VMK1 and VMK2. Also, I want to show you in the summary that on this server I have 6 NICs. So there are 6 NICs available on this server. We can go and look at the physical adapters, and here they are. I have NIC 2, 3, 4, 5, and 0 and 1. 0 and 1 have been allocated to vSwitch 0, and the other 4 are unused at this point in time. Switching now to the command line, I've logged in as root, and we will key in ESXi network. Hit the enter key. And we will see that we have quite a few namespaces available. The first one is firewall. And it's a set of commands for firewall related operations. Now in the security section, I will deal extensively with the firewall, and we'll actually go in and add new services to the firewall. It involves XML and so on. So we'll take a good hard look at managing the firewall. So just to give you an idea what it looks like, ESXi network firewall, and then we have options of get the firewall status, load the firewall module, and the rule sets. So we have to specify the rule sets, and I'll show you how to define new services and new rule sets later on. But we can do a get, and we can check the status of the firewall. And the default action is drop, which is a good thing. So if it doesn't meet the criteria, it drops it, and the firewall is enabled and it's loaded. So enough of the firewall. We are going to then look at the NIC, which is operations having to do with the configuration of network interface cards and getting and updating the NIC settings. So let's take a look at that. I'm going to clear the screen here. ESXi network NIC list. Now, if you recall, in the web client, I had actually showed you we had 6 NICs. So they're from VMNIC 0 all the way through VMNIC 5. So that's how they actually show up here. So you have the name, then you have the PCI device, you have the driver. This is interesting because when you look at the driver, there are 2 sets of drivers. There's the E1000E set of drivers for 2 of them, and then you have the IGB drivers for the other 4. It's because the E1000E drivers are actually running on the 2 NICs I have on the motherboard, and then I have 2 extra cards in there, each with 2 ports, which are Intel, and that's why I'm running the that's why the ESXi runs the IGB driver on them. As you can see, this one is actually interesting because when you look at the speed, so the links, well, look at the link status and the admin status, right? So they are up and running logically, administratively, as well as physically. They're all up and connected here. If you look at the speed here, it's 1000, 1000, 1000, and then I have one NIC that's running at 100 megabits, but it's running at full duplex. It's actually plugged into a different port. It's in a wireless router actually, and so the speed is 100 megabits. All the others are plugged in directly into a a very sophisticated 1 gig SDN switch on which I do a lot of experimentation. Let's look again. ESXi network NIC. Let's look at the other commands possible for NICs. So network NICs VLAN. I'm running all VLAN ones at this point in time. Let's look at stats. So network NIC ATS get, and we need the name of the NIC. Okay. Now, what does this mean? Is it VM NIC 0? And the answer is yes. So if you look at this is my management port NIC, of course. It's been a lot of activity. Packets received, packets sent, received. Nothing has been dropped. I'm also getting some multicast, which is interesting. I wonder where that is coming from. But apart from that, there are no errors. So everything looks really, really good on my NIC statistics for VM NIC 0. And this is a good way of actually checking the status of your VM NICs. Not so much the status, but are things working really well? The other way, obviously, is to do it with ESX top and some other commands. But this is a very simple way of doing that. So let's clear the screen to get to the top. And we again look at network NIC options. Some of the other spaces would be commands to access would be this one, commands to access TCP segmentation offload settings for a NIC. Now all modern NICs actually have this capability, and it's all usually on by default. So we'll try that. We'll clear the screen, retrieve network NIC TSO. It'll probably ask me for one more. I'll say TSO get. And you can see that TCP segmentation offload is on the VM NIC, which means that all the segmentation activities are being done on the NIC itself and not either in the device driver or in the network stack or somewhere else. It's done in hardware, which is obviously a good thing. Let's look again at network NIC options. Get a VLAN. I could show you this. I just have VLAN 1 running at this point in time. Now these are also interesting. Coalesce commands. Again, these have to do with how packets are received, and then for a certain flow, and then how do you send them immediately, or do you wait for a while before you send them off? So, are you doing the interrupt each and every time you receive something, or are you coalescing first and then sending it out? This obviously reduces the load on the CPU. If you wait for a certain time, send it, but that increases latency. So that's something that would interesting as well. We can take a look at that. Coalesce, CLEAR, network NIC. Is that how you spell it? And we get that. Okay, so it looks like on all of these everything is off, so there's nothing going on there. It's really doesn't seem to be coalescing anything either on receive or on transmit. Clear it again. Let's look at network NIC IP, another namespace. And we see DNS, which obviously has to do with domain name server. Operations having to do with creation, management, and deletion of VM kernel interfaces. So obviously what it's telling you here is that you can manage VM KNICs. IPsec, route configuration. So we look at some of these. NetStack. I will be looking at, this is how you create a custom TCP IP stack, which I think is in the next video. So I'm not going to do that at this point in time. Let's look at DNS, and then we will look at interface. S, probably get. It's server. List. So the DNS server is defined in our stack here, which is probably good. The default stack, default TCP/IP stack is my local router as well as out in my provider network. And of course, I can add a new DNS server. We can give that a shot. List. So list, we say add. Let's check the syntax here. So I can use a net stack, or if it's unspecified, it'll go onto the default network. I don't think at this point I have another custom stack set up there. So we will just add a server up here. So it would be DNS server add -s, and we can add this DNS server to the mix. When we retrieve the list, well, that's added on. So reasonably trivial, but it tells you that everything is can be done up here. So apart from DNS, let's look at some other ones as well. The next would be interface, IP interface. Hit enter key, and we can either add a new VM kernel interface. Much easier to do it actually now on the web client, but back in the day, this is the way it was done. Also, if nothing else is working graphically, hard pressed to understand why that would be the case, but if it is, then you can always go in here. So first we'll list them, and then we'll take a look. And the important part is this one. For this command, sets the enabled status and the MTU size of a given interface. You can obviously change the MTU here. You can change the MTU graphically as well. So much of these really have been taken over now by the graphical user interface, but it still exists. So we can do a network IP interface IPv4 list v4 get, and as we saw earlier on the web client, there were three VM kernel interfaces there: VMK0, VMK1, VMK2, and obviously that's my management. And these are two that I'd created for use with the custom stacks. Okay, what else do we have here? IPv4, under IPv4 namespace, let's see what we have. Let's see what we can set. The options are, you obviously need the interface name, so the VMK. The static address can be changed, the net mask can be changed. Whether it's your DNS system should DNS via DHCP. Usually if you're using DHCP, then the DNS settings do come with it, and that's usually the reasonable thing to do. The type, IP address type, is DHCP none or static, so we can set a static address, or we can basically remove the IP4 settings or start using DHCP. Again, we go through the same procedure here, so I'm not sure if this is something that you would be interested in actually looking at, but we can give it a shot. We will try the set -i VMK1. We'll take a different one, and we'll say that it's going to now be a DHCP, so it's going to dynamically retrieve its address. Okay, and that's basically that. It actually does that. We clear this, and we look for some ESXi CLI network. Let's look at some other spaces. Network, and look at some other options. vSwitch is obviously network, and the syntax here is kind of interesting because you can key in a standard switch standard, and it'll if you list a list, it'll give you all the standard vSwitches that are there. So of course, as we saw earlier in the graphical user interface, we have vSwitch 0. It's an Ether switch, number of ports, 8 ports used. CDP is working both ways, and and we have this. Then we can look at network switch, vSwitch, DVS, VMware, because there are different switches, and we can say list, and obviously this will not give us anything because we don't have anything running right now. We don't have a VDS. Now in this it's called DVS, VMware, LACP, config, get. Okay, LACP support on the VMware DVS switch only, and there is no distributed switch configured on the host. Thank you. That's very useful to know. ESX CLI network. There's a lot we can do with actually standard switches, but again, these are what I consider to be old-fashioned commands, because everything is almost recoverable nowadays, especially the distributed switch, because you can export the configuration and you can re-import the configuration, and you can reset the configuration. In fact, if you do something bad, the system recognizes it. If you're going to lose connectivity to your system, it recognizes it and doesn't let you complete it. Well, again, a few years ago that was not the case, and so most of these commands were really useful at that point in time. So we switch standard. We'll just go through a couple of more. We can say with an add command, we can add a new standard switch in there. Again, if you don't have the graphical capability available for some reason through either the web client or even the classic client, or even directly into the host, well, this is one way you can do it if you can get to the ESXi shell either on the console or via SSH. Let's take a look again at ESX CLI network NIC list. When we do that, let's focus on the drivers. So there are two NICs on the motherboard. They're using the E1000E driver, and there are two cards, each with two ports, which are running the IGB driver. So ESX CLI system module list, and we will pipe this to more, and we get a list of all the drivers that are loaded. So you can say from the is loaded column, this is true, and is enabled, so that's true as well. So they're up and running, they're loaded and running. So you can see there's a whole bunch of drivers, a lot of iSCSI stuff, EtherSwitch stuff, and so on. When we keep going, and we see right here IGB and E1000E. So those are also loaded and enabled. When we keep going, these are the PSPs and the SATPs. This is part of the storage architecture that's in place. So we'll deal with that later, the PSA. Keep going, Shaper, LLDP, CDP drivers, of course. MegaRAID SAS, because I'm actually using card from MegaRAID, and you can see some FCOE drivers, some FC drivers. Here's an LACP drivers. VMCI is for inter-VM communications. It's not really used, but when I reviewed it again, the VMCI inter-VM communication, it completely smacked to me of exactly what we're seeing right now with Docker containers. The way Docker containers communicate amongst themselves, and the fact is that you can actually intercept traffic there, and that's why this is deprecated, so to speak. I'm not really sure why it's actually enabled or even loaded here. Enough said. Let's move on to see what else we have. We have the Vsphare, the UFS, the VMSFS3, and there will be some other ones as well here. We have the Flash, and here we have the new NFS version 4 client. Okay, so the ones we are interested in right now are the two NIC drivers, IGB and E1000E4. Let's now look at the parameters for these modules. So ESX CLI system module parameters list for the module IGB, and we'll pipe it to more. And we get the name of that parameter here, the type, its current value, or if it's default, it really doesn't actually show up there. That's how I read it, and description, what it actually does. So you can see it here. There's something called DMAC, which disables or sets the latency for the coalescing. So 0 is off. The other values can be in milliseconds up here. Okay. Then we have low latency interrupts, TCP push flag. Here's RSS, so the number of receive side scaling descriptor queues. Normally it's set to 0, or sorry, default is 1 queue. 0 means nothing is being received. Default is 1. If you put in 0, that's the number of CPUs which are available. So let's see if we can change this. So the name of the parameter is RSS in capitals. So we control C out of this, and we look at system module parameters set. Okay, and hit the enter key. And we'll see that what we need to do is to give the name of the module, and with a -p the parameter and the string. Okay, so let's clear this, and system module parameters set dash module is IG b dash parameter is RSS equals, we'll see if we can change from 2 to 3. Well, I don't like odd numbers here, so we'll make it 4, which makes it the same as the number of CPUs. And when we go back to parameters list for IGB, we should see that RSS, the value is now 4. So this just gives you an idea of the kind of things you can do with the command line. You can actually go right into the driver and fine tune it for your requirements. Again, normally it's unnecessary, but there are low latency and some very high throughput requirements sometimes where you have to go in there. Again, work with VMware support, but it's good to know that these things exist, and not to be worried about changing them if you know what you're doing. And don't do it on a production system. So we spent quite some time looking at the ESXi CLI for networking. We examined many commands, especially in the ESXi network namespace. We looked at the IP commands. We looked at the virtual switch commands. We extensively looked at the NIC commands. We then looked at the system modules that were loaded for certain NICs. There were 2 NICs in this host that were E1000E. The others were IGB. Using the ESXi system module parameters list for IGB, we listed the parameters and we changed the receive side scaling queue number from 2 to 4 by using the ESXi system module parameters set -m and then IGB and -p for parameter, and then within quotes we said capital R, capital S equals 4 and close quotes, and that basically changed that value to 4. So again, things you can do to your system and to fine tune it, again to be done only when absolutely required. Don't do this on your production system. Again, work with VM support, and only if they say so should you make these changes to running systems. So with that, let's now look at our next video, which should be custom TCP IP stack. So this is a wonderful capability now available in ESXi 6 or vSphere 6 suite to be able to create your own custom TCP IP stacks. Exciting, and I hope to see you there.